Okay guys, just a little follow-up video to the previous video on the hardware components. So in terms of the software, in one of my previous videos I showed you how I made this plaster mold of the repulsine. Now I spent about 2 weeks really almost totally destroying the mold, figuring out how to extract forms from it. I wanted to slip cast, but it was a little bit too challenging. The complexity of the mold does not lend itself well to slip casting. So what I decided to do is using latex. So this is latex rubber. What I did, the process, I soaked and then soaped this mold over and over and over, soaped it many, many times. What the soaping does is seals up all the pores. And then I sprayed a mold release down on the surface and laid up latex. So the first couple layers were a watered down latex to pick up all the surface detail. And then the upper layers, as you can see, these are pretty rough, the last layer being quite rough. So what this is called is a master. So that is a rubber master. And I learned how to do this from this book here, where they explain how to make master molds. So this is the rubber master. And then what you do, you pour your rubber in, and then you rough up the surface. So I roughed up the surface. And then you pour, here they pour plastered. It's called a plaster mother mold. So the mother mold supports the rubber master. In this scenario, the mother mold is going to be wax. And what happens here is this makes this whole setup, when I pull it out, electroforming safe. So I can paint the latex with the copper paint and then plate onto the latex. So this is going to be my strategy for producing these forms. What I wanted to do was to derive a wax form directly from the plaster. So the plaster is a negative of the part that I want. It's the sort of negative image. The latex will be a positive. And this is important in terms of shaft sizing. The reason for this, if you'll follow me, considering the last video, I'm going to be using 1 1/4 inch shaft. So this is a section of the half egg-shaped hub into which the horns will fit and solder into place. So on the half egg-shaped hub, I have a 1 1/4 inch nub, and my shaft will fit into that. So when I electroplate onto my positives, this is a positive. When I make the plaster, I make the negative. And then when I make the latex and wax form, that's a positive. In electroforming, when you plate on the positive, you plate from the ID to the OD. So your finished part, your ID will match exactly your whatever you have on your positive. So keeping that in mind, the half egg-shaped hub is going to slide directly onto the shaft. The half egg-shaped hub is going to have a lid and a flange. The reason for this, because I want to get inside of the hub to solder the pipes into place. So there'll be a lid with a flange. The lid is going to be kind of complicated to make. Basically the lid is going to take the form, because the lower membrane is also going to have slots in it. So the lid will have these pressure gills as an integral component. So when the lid fits into the lower membrane, it will serve as the pressure gill component to the underside of the membrane. Okay, so that's the half egg-shaped hub. It's going to be 1.25 inch shaft, which will extend into the base of the drum. 3 horns will spiral around the shaft, solder into these 3 openings, which I'll have access to from within, and then the lid will be installed. That will be bolted. I'm not sure how I'll fix the lid to the half egg shaped hub. So that will be bolted or some other way. And then the lid has a inner diameter of 1.25 inches and an outer diameter, a finished diameter of about just under 1 3/8 inches. So when I make the lower membrane, I have to use a ID of 1 3/8 inches. And then when I make the upper membrane, I have to use a shaft with an ID of 1.5 inches. So what that does is allows each of the shaft components on the turbine finished parts to slide into one another. All right, I don't know if that made sense, but this is the software component. This is the strategy I'm going to use to generate the upper membrane, lower membrane. So I'm going to create, this is just an experiment. I have new spline drawings here. So I'm going to do this all over again. And my plan is to produce on the pottery wheel an upper membrane, a lower membrane, and then the lid section I will derive from the lower membrane's plaster form. I'll make plaster forms of all of the clay forms, and then from the plaster I can derive the master and the mother. So I'll have an upper membrane. I won't carve the turbine blades the way I did the last time. I'll just have this like cowling. The lower membrane will match this profile, except for here, it won't match the profile. It will mirror the profile. Reason for this is because I'm going to make the turbine wreath as a separate component. That way, if I get the direction of things wrong, all I have to do, so I design it so that as this spins counterclockwise, the turbine blades fling the water in the direction of rotation. But if I'm wrong, all I have to do is flip my wreath, and I have the same profile. I just fix it to the bottom instead of the top, and then my wreath around the drum's periphery, I can do the same thing. Just flip it. That's in case I get something wrong, which you know is quite likely. But this is the new profile. I went with a steeper curve, and basically the way I drew this is triangles and angles, and then I drew the spline into that, if you can see. So those are 70-degree lines, 65 degrees, tapering all the way down to about 22 degrees there. So I'm really just trying to get the right profile on paper, and then I'll make the new ribs. I'm gonna make 2 identical ribs and attach them to a hinge and really make a useful tool for templating on the pottery wheel. All right, so that is an explanation of how all those components are gonna go together. I make the positive on the pottery wheel out of clay. I pour a negative in plaster, and the reason I'm pouring the negatives is because I want to preserve the dimensions of the clay, and because clay shrinks, and I don't have the time to fire these things, what I'm going to do is basically translate the clay into plaster so that I have a more stable form, and then from the plaster I can derive masters and mothers for the electroforming baths. Okay, so then just a little final note here in terms of clay. I think when I set this whole machine up, one of the first things I'm going to experiment with as a medium to be moved is not just plain water, but I'm going to use some kind of slip formulation, a pottery slip formulation. And the reason for that is because slip and clay is like a magnet, basically. Clay particles, when they stick together, this is almost identical to magnets sticking together. Explain it in this chapter here. What happens is when you deflocculate clay with sodium silicate, you change the positive electrical charge on the edge of the clay plates to a negative charge. And as a result, all the clay particles repel one another. And while I was screwing up, over deflocculating my clay and almost destroying my mold, I realized that clay, doing a little bit more research, would be a very interesting particle to move in these machines. Mainly because, for example, with a kaolinite clay, you have your gibbsite sheets in clay and your silica sheets. The silica sheets in clay are tetrahedral in shape, silicon, and 4 oxygens. And the way that they bond together into a chain nets a charge of -1 for these silica tetrahedral shapes. So all clay consists of 2 main building blocks: silica tetrahedral shapes, and then these gibbsite sheets, which are, if I can read my own writing here, they're octahedral in shape. They contain 6 OH and aluminum 3+. It doesn't have to be aluminum. If the aluminum swaps out for something like magnesium, they call that isomorphous substitution. And if you substitute aluminum for magnesium, you get bucite sheets. Anyway, when you stack these sheets, so you have a gibbsite, silica, this particular arrangement of kaolinite, the silica and the gibbsite are, if I'm pronouncing that wrong, I'm sorry, but the bond there, you get a hydrogen bond. So there's different bonds in different clays. Hydrogen bonds. In the illite clays, you have potassium bonds, which are weaker than hydrogen bonds, but stronger than the van der Waals force of this clay, which I can't even read my own writing there, sorry. So what I'm thinking is, I have a drum, I have this suction turbine. You know, what if I moved a slip formulation through the turbine? What would happen? The hydrogen bond is the strength of this hydrogen bond, what it does is it reduces the amount of water absorption in a kaolinite clay, so you have less shrinkage. But that hydrogen bond